Heavy machinery begins the initial leveling of the sand dunes to establish a stable foundation for the farm. Specialized tillers integrate organic matter into the sand to enhance the nutrient profile for future plant growth.
Reflective polymer sheets are deployed to manage ground temperature and prevent moisture evaporation in the arid climate. Laser-guided systems ensure the ground is perfectly level to facilitate uniform water distribution across the entire field.
Subsea irrigation lines are anchored securely to prevent shifting during the high-pressure.
Raw seeds enter the primary cleaning stage, where vibrating screens remove all debris and undersized organic particles. Optical sensors identify and eject defective seeds, using precise bursts of compressed air to ensure high germination.
A specialized polymer coating is applied to the seeds to provide essential nutrients and initial disease resistance.
Controlled heat exposure cures the protective seed coating to ensure durability during the mechanical planting process ahead. Finished seeds are vacuum sealed and palletized to maintain their integrity until they reach the desert planting.
The precision seeder injects treated seeds at exact depths to optimize the contact between the seed and soil.
Each seed is followed by a localized moisture mist to initiate the germination process in the dry sand.
Autonomous tractors work in synchronization to complete the planting of several thousand acres within a specified time frame.
The first green shoots emerge through the protective film, signaling the successful start of the desert cultivation.
Field technicians perform manual checks to ensure that the environment remains conducive for the fragile early growth stages. Real-time data monitoring allows for the precise adjustment of water delivery based on the specific needs of plants. Overhead misting systems activate automatically to reduce heat stress when desert temperatures exceed the optimal growing range.
Drones apply foliar nutrients directly to the leaves, ensuring rapid absorption and minimizing waste in the soil.
Automated rovers utilize UVC light to neutralize pathogens, reducing the need for chemical fungicides in the field. Soil sensors provide constant feedback on moisture and salinity levels to maintain the perfect balance for roots. The on-site desalination plant converts brackish groundwater into high-quality irrigation water for the thirsty strawberry crop.
The appearance of blossoms marks the transition from vegetative growth to the critical reproductive phase of development. Managed bee colonies are introduced to the fields to ensure maximum pollination and high fruit yields per plant.
The localized weather stations provide data used to predict evapotranspiration rates and adjust the daily irrigation schedule accordingly.
Small green fruits begin to develop, requiring a shift in the nutrient mix to support sugar production.
Bird netting is inspected and secured to protect the developing fruit from local wildlife and potential pest damage.
The stark contrast between the green crop and the desert sand highlights the success of the irrigation system.
Thermal imaging identifies areas of heat stress, allowing for immediate intervention through localized cooling or increased water.
The shift in color indicates the onset of ripening, a stage where sugar levels are closely monitored. The Brix testing ensures the strawberries reach the desired sweetness profile before the final harvest schedule is finalized. The strawberries have reached peak maturity and are now ready for the synchronized harvesting operation to begin.
Mechanical harvesters use soft grippers to pick the fruit without bruising the delicate skin of the strawberries.
Skilled workers provide a secondary harvest to ensure that every viable fruit is collected from the desert plants.
Harvested crates are immediately moved into shaded trailers to prevent the sun from degrading the fruit quality.
Protective covers are applied to the harvest to maintain a stable temperature during the short trip to processing.
Electric trucks provide a sustainable transportation solution for moving the high-volume harvest from the field to the factory. The arrival at the refrigerated intake bay is the first step in the cold chain preservation process.
Rapid pre-cooling is essential to slow down the metabolic processes and extend the shelf life of strawberries.
Forced air cooling quickly reduces the internal temperature of the fruit to the optimal storage level of 1 degree.
Chilled water jets remove any remaining desert sand and dust from the surface of the harvested fruit. A sanitizing bath ensures that all surface bacteria are neutralized before the strawberries move to the sorting area.
High-velocity air knives strip away residual moisture to prepare the fruit for high-speed optical sorting and grading.
The 360-degree optical sorting technology evaluates each strawberry for uniformity and quality at a rate of thousands per minute. Fruit that does not meet premium fresh standards is diverted for secondary processing into juices and preserves.
Automated scales sort the premium fruit into weight-based categories to ensure consistent volume in every final package. Human inspectors provide a final layer of quality assurance to verify the accuracy of the automated sorting systems.
Recyclable clamshell containers are automatically fed into the line to be filled with assorted premium strawberries.
Precision filling heads dispense the exact weight of strawberries into each container with minimal physical contact. The lids are securely closed by a mechanical arm to protect the fruit during the final labeling process. High-speed batch numbers and expiration dates are thermally printed onto the packaging to ensure full traceability and consumer safety. Integrated metal detectors scan every package as a standard safety protocol before the final boxing and palletizing stages. Robotic case packers efficiently organize the individual containers into cardboard shipping trays for bulk transportation. Shipping trays are stacked onto pallets according to a specific pattern designed to maximize airflow and stability. Automated stretch wrapping secures the palletized load, ensuring the cases remain intact during the international shipping process. Finished pallets are moved into cold storage to maintain the cold chain until the transport trucks arrive.
Refrigerated trucks arrive to transport the desert strawberries to the nearest international airport or shipping port.
The loading process is conducted in a temperature-controlled environment to prevent any thermal shock to the fruit. With the doors sealed and the refrigeration active, the strawberries begin their journey to global markets. The logistics network ensures that desert-grown strawberries can reach international destinations within 48 hours of harvest. Digital temperature loggers track the environmental conditions throughout the entire journey to guarantee the product's freshness.
Air freight is utilized for high-priority shipments to ensure the strawberries arrive at peak quality in distant markets.
For regional distribution, refrigerated shipping containers provide a cost-effective and reliable method of transporting large volumes.
The global distribution network connects the desert farm to major urban centers across 3 different continents.
Upon arrival at the retail destination, the strawberries are immediately displayed in temperature-controlled produce sections.
Consumers can scan the on-package QR code to view the journey of their strawberries from the desert.
Transparency in the supply chain provides consumers with confidence regarding the origin and quality of their food. The success in the first phase leads to the expansion of the farm into adjacent desert territories.
Water sustainability is achieved by recycling industrial wash water and returning it to the field for irrigation.
Maintaining the solar array is critical for providing the renewable energy required to power the entire operation.
Post-harvest soil analysis allows for the precise replenishment of nutrients before the next planting cycle begins. The organic waste from the strawberry processing line is composted to create nutrient-rich soil amendments for new fields.
On-site manufacturing of irrigation components reduces the carbon footprint and costs associated with transporting large-scale infrastructure.
The desert farm operates 24 hours a day, utilizing automated systems to maintain the crop during night. Daily drone flyovers provide high-resolution data that helps identify early signs of plant stress or nutrient deficiencies. Instantaneous adjustments to the irrigation valves ensure that every section of the farm receives optimized water delivery. Windbreaks are maintained to protect the strawberry plants from the abrasive effects of sand-laden desert winds. The desert farm serves as a global research hub for studying plant resilience in extreme arid environments. Rigorous sanitation protocols are followed daily to maintain the high standards required for international food export. Testing new cultivars ensures the farm remains competitive by producing varieties with improved flavor and heat tolerance. Regular calibration of the optical sensors is necessary to maintain the highest level of sorting accuracy possible. The integration of wind and solar power provides a redundant and sustainable energy supply for the farm. Sustainable packaging initiatives include the use of recycled cardboard for all secondary shipping and storage containers. Every movement in the packaging process is engineered to minimize impact and preserve the delicate fruit structure. Nitrogen flushing replaces oxygen in shipping containers to slow down ripening during the longest international transit routes. Precise timing is the backbone of the operation, ensuring the strawberries reach their destination at peak freshness.
Shade cloths are deployed during extreme heat waves to prevent the young plants from suffering irreversible thermal damage. Monitoring the salinity of the runoff ensures that the desert soil remains healthy and free of salt.
Automated storage systems allow for the rapid retrieval of specific batches to meet the demands of retailers. The final export stage involves the careful loading of pallets into the cargo holds of international aircraft.
The desert farm represents a harmonious blend of advanced technology and nature, producing food in extreme conditions.
Final taste tests confirm that the desert-grown strawberries possess the superior flavor and texture required by consumers.
Real-time production statistics provide management with the data needed to plan for future expansion and market growth.
Routine maintenance of the desalination system is vital for ensuring a continuous supply of clean irrigation water.